Hi everyone, we have a question from rotatory mechanics. The question is, there is a uniform rod of mass m and length L. It is allowed to fall on the ground from the hinged position at O. Now what will be the angular acceleration and angular velocity on reaching the ground? For that, let us assume any arbitrary position of the rod. This is the position of the rod at any instant of the time. Let us consider this angle is theta. We all know that according to the Newton's second law of motion, torque acting at the center of the rod is torque about the center is tau is equals to I alpha. The weight of the body is acting downwards. So this weight is producing the torque. So the formula of torque is force into perpendicular distance. As the total length of the rod is L, the distance between O and center of mass of the rod is L by 2. So the torque is force into perpendicular distance. This is the perpendicular distance. As it is L by 2, this will be L by 2 sine theta. So mg L by 2 sine theta is equals to I alpha, where I is the moment of inertia of the rod about the one end. About the center, moment of inertia is ml square by 12. By using parallel axis theorem, moment of inertia about the center is equals to, about one end is equals to moment of inertia of the rod about the axis of center of mass, ml square by 12 plus m into perpendicular distance between two parallel axes, that is m L by 2 whole square. It gives ml square by 3. So from the equation 1, we can write mg L by 2 sine theta is equals to ml square by 3 into alpha. From this, alpha can be written as alpha is equals to mgl sine theta into 3 upon 2ml square. M get cancels out, L and square get cancels out. So the angular acceleration alpha is equals to three g sine theta upon 2L. So this is the general form of angular acceleration. We know that alpha is equals to d theta by alpha is equal to rate of change of angular velocity omega, d omega by dt. So 3g sine theta upon 2L is equals to d theta, d omega by d theta into d theta by dt, as we don't know the time. So 3g sine theta upon 2L is equals to omega d omega by d theta. From this, omega d omega is equals to 3g by 2L into sine theta d theta. By integrating on both sides, omega is varying from 0 to some omega after some angle theta, and theta is varying from 0 to theta. Omega d omega is omega square by 2 is equals to 3g by 2L into integral sine theta d theta is minus cos theta to the limits 0 to theta. So 2 get cancels out. omega square is equals to 3g by L into cos 0 minus cos theta. As I have removed the negative sign, interchange the limits. So omega square is equals to 3g by L into 1 minus cos theta, since initial cos 0 is 1. Omega is equal to root over 3g by L into 1 minus cos theta. This is the formula of angular velocity. In the question, what they have asked is on reaching ground or horizontal, theta will become 90. So angular acceleration alpha is equals to 3g sine 90 upon 2L, and angular velocity omega is equal to root over 3g by L into 1 minus cos 90. So alpha is equals to 3g by 2L, and omega is equals to root over 3g by L